Laptops are no longer just PCs. They're becoming AI compute nodes. For more than a decade, the laptop market was driven by replacement cycles. Consumers upgraded for better CPUs. Companies refreshed devices on fixed schedules. Sales peaked during back-to-school seasons and year-end promotions. Performance competition slowly converged. Margins stayed under pressure. And innovation became incremental rather than structural. That model is now breaking. Since 2024, laptop demand has quietly changed. Starting in 2024, a different type of demand began to emerge. Local AI inference, content creation and model testing, edge computing, and real-time workloads. Laptops are no longer treated as simple display terminals. They are increasingly expected to act as lightweight compute nodes. Efficiency per watt, memory bandwidth, and system-level integration now matter more than raw specs alone. NVIDIA is not testing the waters. It's entering the high-end segment. Directly, recent Geekbench results of NVIDIA's N1X engineering samples show a clear signal. Single-core performance is roughly on par with Apple's M3. Multi-core scores approach M3 Pro territory. This is not an experiment. It is a direct entry into the high-performance tier. Supply chain data already shows multiple OEM models under development, including Lenovo's Yoga and Legion series. Productization is not theoretical. It is underway. The hardware configuration signals platform intent. According to current disclosures, NVIDIA's N1 and N1X platforms combine a 20-core CPU design, RTX-class integrated graphics, system-level integration typical of advanced SoC architectures. Several confirmed models include IdeaPad Slim, 5, 14, and 16-inch variants, Yoga Pro 7 series, Yoga 9, 2-in-1 Legion. 7 performance line pricing estimates place N1X laptops near the $4,000 range. Market projections suggest potential sales of 9 to 12 million units, with NVIDIA maintaining gross margins near 50%. This would translate into a meaningful EPS contribution as early as Q2. The core question is not performance. It's platform value. The real issue is not whether these laptops are fast. The question is whether high-end laptops are transitioning from upgrade-driven products into AI compute platforms. And the answer increasingly points to yes. Demand-side shift. AI workloads create structural requirements. AI inference latency, data privacy, and real-time interaction are difficult to fully outsource to the cloud. Developers and creators now care about performance density, memory, bandwidth, energy efficiency per watt, LLM inference, multimodal pipelines, and real-time image processing push laptops toward workstation-like roles. This is not optional demand. It is structural. Supply-side constraint. System integration raises the barrier. Modern SoC designs integrate CPU, GPU, memory, and I/O into a single package. That raises requirements across the entire stack. Advanced process nodes, CoWoS class packaging. BF, substrates high-power thermal solutions. Capacity expansion in these areas takes time. Supply response lags demand growth. This is not a fast-adjusting market. Cost structure is shifting toward technical modules. In high-end SoCs, value no longer concentrates in assembly or motherboard design. Instead, BOM cost increasingly flows into advanced packaging, high-bandwidth memory, thermal, and power management systems. This creates a structural redistribution of value across the supply chain. Traditional PC cost logic no longer applies. Regulation and ecosystem are reinforcing local compute data sovereignty. Privacy regulations. Latency-sensitive applications. All of these push compute workloads closer to the device. The maturity of the Windows on ARM ecosystem will directly determine how fast this shift accelerates. But the direction is already set. Why CPU-GPU integration actually matters. SoC architectures allow CPU and GPU to share a unified memory pool. This enables zero-copy memory access. It removes PCIe transfer overhead. It reduces both latency and power consumption. For LLM inference and multimodal processing, this is not a marginal gain. It is a fundamental efficiency improvement. The implications are structural. Memory demand is no longer tied to PC cycles. It is increasingly driven by AI workloads. Advanced packaging capacity may face constraints similar to previous CoWoS shortages. Thermal and power modules become central value drivers in laptop BOMs. This is not a spec race. It is a systems shift. Why NVIDIA is entering the CPU market now. NVIDIA has had the technical capability since at least 2020. But at that time, Windows on ARM was immature, AI workloads had not shifted to the edge. System-level packaging costs were prohibitive. Between 2024 and 2026, all three constraints eased simultaneously. Platform economics finally made sense. The real transformation is not about laptops. The rise of high-end laptop value is not about form factor. It is about AI workloads moving closer to users. It is about integration barriers rising. And it is about value concentrating in advanced technologies rather than visible specs. Laptops are no longer just personal computers. They are becoming part of the AI infrastructure layer.